start. Oh no. What?
Hey guys, so in this video we're gonna make some lava coming out of the screen. We're gonna use Adobe After Effects, Blender, and for the simulation we're gonna use Houdini. So let's get started and see what we can do here. So I have After Effects open here, and that's my footage right here. And you can see there is a bit of movement in it. So the first step is going to track the camera movement in the video. So for this we're going to use Adobe After Effects, and it's extremely easy to do. And yeah, I'm also going to give you the link to the same video in the description down below so you can follow the tutorial. Yeah, where I was. Oh, okay. So let's track the camera. Right here, I have the footage here. Select the footage. Go to the right side panel. You will see tracker. If you don't see the tracker, you can come up to window, and right here you can turn on the tracker and you will be able to see these options. So select your footage, click track camera, and wait for it. Now it's going to take a bit of time. It depends on the duration of your video as well as the frame rate of your video. Mine is 60 fps, so that's why it's going to take a bit of time. It's around 842 frames, and yeah, it's going to take about 6 minutes. I'm going to pause the video here, and once it finishes up I will start it again. So now the tracking is finished, and as you can see, everything looks cool. So now what's the next step? Well, the next step is to create the camera. Right now we don't see any camera in the timeline, so let's create it. In order to create the camera, you have to do it in the viewport. So select your footage, select the effect, and then come up here. As you can see, it creates these little representation. So I'm gonna select these three, and I'm gonna right click and I'm gonna click create solid and camera. Now it created the camera as well and also the solid. And why are we creating the solid? Well, when you export it into Blender, you will be able to see the solid very helpful. It help you spot your specific area. We're gonna talk about it later on, but right now just do what I'm doing, okay? So I'm going to rotate this, and I'm also going to scale it up a little bit so we can see it right here like this. I'm gonna rotate it. Okay, cool. Now select the footage again and select the effect, and right here we're gonna create some points on the screen. So I'm gonna hold the left and just drag around to select multiple points and right click create solid. Now we created another solid here. If I select this, I'm gonna click S and I'm going to scale it up like this. I can rotate it like so, and yeah, that's how you do it. I'm going to move it a little bit up, and then I'm going to scale it up. Now this representation help us find a specific location in our footage. Like for example, in 3D, if I wanted to add something into the screen, now this solid will help me add the specific object into this specific location or maybe position. Yeah. And also these other one also help us add stuff into the table. So right now, if you have a look into the video right here, as you can see, the solid stick into its place, and that's exactly what we want. And it's looking pretty good, I think. Yep. Now it's time to export these data into Blender, and maybe we can add some more solid before we export it. So I'm gonna select it, and I'm going to add some more solid. I'm gonna select these, right, and create solid, and some of these on the keyboard. Right click, create solid, and right here, maybe I would like to create one here, create solid, like this, and I'm gonna turn this into full so we can see the full resolution of the video. Okay, so after you do all these steps, after we track the motion, create all the solid, now it's time to export it. Now there's a bunch of ways to export data into Blender from After Effects, but the method that I'm gonna use is an add-on which is created by NPS 3D. Now this add-on is called Aeblink. Now what it does, it basically helps you export data into Blender. You track the motion in After Effects, you export it into a specific file format, and then import that format in Blender. That's it. So in order to install this script here, once you download the add-on, you will be able to find it. In the zip file, you will find two files. One will be a JSON file and one will be a Python file. So first of all, you come to File, you come to script and you click install script file. Once you click this, you go to the folder where you have downloaded Aeblink. I have it here. As you can see, this is the JSON file. This is what we are installing right now. So select it and click select and install it. It will install the script file in After Effects. Once you install the script file, what you can do here is you can select your entire composition, go to file, go to script, and right here you will find it, Aeblink script v1. Just click it. Now it's going to export the camera, the solid, and the nulls. Click export. Now you can select a specific folder where you want to save the Aeblink file. No, sorry, JSON file. So I'm gonna call it track, and I'm gonna click enter and save the file. Now as you can see, it says export successful. Just click got it. Now it's time to open up Blender. So I'm gonna search for Blender and I'm gonna open up Blender here. Okay, so once you open up Blender, you have to install the add-on. Now I just find it a bit confusing, but this is a bit different from the other installing add-ons. You might think I will go to add preferences and add-ons. I don't know, for some reason I have to go to the script in here. I'm gonna click open, and right here I have to go to add-on Aeblink. Right here I'm gonna click this Python file that comes with Aeblink. I'm gonna click it and click open text. Right here there's a bunch of codes. I don't care, just click the run button and it will install the add-on for you. If you go back to layout, right here you will be able to see it. I know it's a bit confusing, but we installed it, so all good. So now it's time to import the file that we exported from After Effects. So I'm gonna click this button here. I'm gonna click it, and I'm gonna go to the location where I have the data. So right here, as you can see, track.json. Before I import it, I'm gonna do some settings here. I'm gonna delete everything in the scene, and I'm gonna go to output settings. Right here the footage was 4K, so I'm gonna do 2160 for the X1, and I'm gonna go with 3840 with the Y. Okay, and the frame rate was not 24 FPS, it was 59.94, I guess. Yep. And then I'm gonna come up here and I'm gonna click this button, and I'm gonna go to the location where I have the data exported from After Effects. It's right here, track.json. I'm gonna click accept and click import. Now it's going to import the data here. Right now everything is extremely messy, so there is a world scale controller. I'm gonna select it. I'm gonna click N to hide this. So I'm gonna go to the side view. As you can see, everything is extremely far away. So I'm going to scale it down like this, like so, and I'm gonna grab it here. The camera got extremely smaller, and we don't want that, so I'm gonna select this one. I'm gonna go to camera settings. I'm gonna go ahead into viewport display, and I'm gonna scale it up. It doesn't affect the scene, but it only helps you see the camera. So okay, so right here, if I add a cube, I just want to compare it with a scale, with a real scale. So that's our cube here, and I think we scaled it too small, so we're gonna scale it big. I'm gonna put it here, and here is the plane here, so I'm gonna rotate it like this, and I'm gonna move it. So if you look at this plane here, this one, we need to match it with the y-axis, so it perfectly rotates like this. You might don't see it, but I can see it, and I think it's perfectly oriented. So I'm gonna go to camera view here. Okay, so in order to import the footage, you can also do it from here, but I'm gonna do it from the background image. So I'm gonna click it, add image. I'm gonna click in a movie clip, and I'm gonna click open, and I'm gonna add the footage. I'm gonna open it. So for some reason I just don't understand it, but I think it is zoomed in too much. Yeah, so for some reason it was like this. It was like this, and I don't know why is that, but I was have to change the sensor fit to horizontal. Now I think it's fixed. Yeah. So everything is on its location, I think, and it's perfectly good. I'm gonna delete the cube. I'm gonna select the world controller and I'm gonna click. Maybe what I'm gonna do here is I'm gonna click Shift A. I'm gonna create a new controller and I'm gonna add it into the center. I'm gonna select the world controller and after that I'm gonna select the new empty and I'm gonna click Control P and keep transform so I can rotate entire thing with this controller right here. So what I'm gonna do is to rotate it like so. So now I can match the orientation of the scene with the X and Y, and I think they're matching. Yep. So now I think the tracking is done. Now it's time to do some other stuff. I think it's sticking very well, and that's looking good. Let's save the file because we might miss it. So it might crash because I don't know. I'm gonna call it a lava simulation, and I'm gonna save the Blender file. And by the way, I'm gonna put the link to Aeblink in the description down below. And it was not a sponsor video. It is just to try the add-on out because the creator of the add-on contacted me. So yeah. And right here you can see things looking good. Let's move on to the next step, which is creating the representation, an overall representation of the scene. So for that, what I'm gonna do here is I'm gonna select this plane here. I'm gonna go into edit mode, and I'm gonna go ahead and open up a new window as well. I'm gonna go to the top view so I can select the different vertices, like for example this one. So I'm gonna move it like so to right here, and I'm gonna move it a bit forward so it matches to one another. I'm gonna select this one and I'm going to move it. I'm gonna change this to local and I'm gonna move it on y-axis. So we are trying to create the screen of we're trying to create a screen in 3D. So and I'm gonna select the downward. I'm gonna move it like so. I'm gonna zoom in. I'm gonna move it on x-axis as well so it matches. Perfect. Now it's time to move the other vertices as well. G, I'm gonna move it into X. Like so. I'm gonna select this vertex and I'm gonna move it up. I'm gonna move these down. Like so. And now if you play it, let's stick into it. And that's what we want. Okay. So now it's time to create the border. So I'm gonna click A and I'm gonna click Alt and E. And I'm gonna say extrude faces along normals, I think. No, it did not work. Control Z. So I'm gonna click E and then I'm gonna click S to scale it. So I'm gonna get back here so I can see the vertices. And what I'm gonna do, I'm gonna click, I'm gonna move it a little bit forward. So I can delete the face and then I can select the other vertices. So I selected all of them, click S to scale it down. I think it's too much, so I'm gonna move it back. I'm gonna go to wireframe so I can see what's going on. Perfect. Now it's time to click E and then click S. Okay, now it's time to match the vertices. G and Y, G and X, like these. And these one as well, G, Y, G, X. And also the other one, G, Y, G, X. And this guy as well. Now it doesn't have to be perfect. We are just making a collider and maybe a shadow catcher, or maybe a holdout, whatever it is. But it's not. It doesn't have to be perfect. It can be. It can look like anything, but we just need the shape or the overall shape of the screen. Okay. Perfect. Now you have to save the file because Blender can crash anytime, so you have to be careful with it. Now it's time to make the table. Okay, I'm gonna go to edit mode and I'm going to select these vertices. And right here, if I just move them into y-axis, right, and this one as well. Maybe I can rotate it on Z a little bit to match it with the corner. Sorry, not the corner, with the edges of table. Okay. And I'm going to select these one as well, and I'm going to click E and X to extrude it on X-axis, and these one as well. So click E and X. Maybe we could play around with the position of that vertex, and as well this one. Cool. Now it's time to select this guy right here. Click E, click Z to extrude it on Z-axis. And I think Control Z. I'm gonna select everything and click I'm gonna go to face, click E to extrude it down. So the entire mesh become a solid, and it helps with collision and stuff. So yeah, perfect. Now if you play it, everything matches up, and that's exactly what we want here. Cool, cool, cool. I'm gonna go to solid mode, and if you play it, well, it matches, and that's what we're looking for. I'm gonna save the file. Now I think we can create more solid objects and more collider to help our simulation, and we can create maybe the keyboard on the table as well as some other objects like the mouse and stuff. You can get those models from Sketchfab and match it with your shot. And yeah, let's do some stuff with it. All right. So then the next step is to um, prepare the screen. Okay, like we should have Houdini opened on the screen, maybe Blender, but I'm gonna use Houdini, and we should have a space for the simulation here. Before we do all that, I'm going to select the main object, and I'm going to come to material. I'm going to create a new material. And before that, I'm going to come up to the y-axis. Which one is the front? I think this one, yeah. Yes, y-axis, go into edit mode, select the middle face here, and I'm going to click U and project from view. And also, I'm going to create a new material. I'm going to click new, and I'm going to click select and invert. And what I'm going to do after that is click assign. So now what it does, the first material is used by the main screen, and the second material is used by the sides. I'm gonna be talking about it later on. Okay, so let's select the first material and go into shader editor. So right here, I'm gonna import the screenshot of my screen. So I'm gonna click Shift A, and I'm gonna go to texture. I'm gonna go to image. I'm gonna search for it. Sorry, image texture, and I'm gonna plug this into base color for now. I'm gonna click open, and I'm gonna go to my screenshot folder, and I'm gonna go there. This is the screenshot, so I'm gonna go into material view. Right now it doesn't fit it, so I'm gonna be opening up a new window here. I'm gonna go into UV editor. I'm gonna click tab to go into edit mode, and I'm gonna select this face. Right here we need to match it with a screenshot, so I'm going to click S and scale it up. But the shape of it is not really good, so first of all I'm going to scale it up like this. And then I'm going to match the corners, so I'm going to select this vertex and I'm going to move it to the top vertex here. I'm going to select this one and I'm going to move it up like so. And then this one. I don't know, there might be a faster way of doing the UV edit like this, but I don't know. I'm just gonna do it manually like this. And then this side as well. Oh. Cool. So now if you look into it, that's how it looks like. And I'm gonna also plug this into emission because screen emits. So yeah, it's gonna do emission of 2 for now. Okay, so my plan is to have this area simulate, okay, like the lava gonna come out of here. So I'm gonna go into edit mode. I'm gonna click double I to inset, and then what I'm gonna do here is I'm gonna go select this edge, click double G onto slide it. Oh, sorry, double G, and why it's not sliding? I don't know, but okay, Control Z. I'm not good at modeling, so I'm gonna go to front view and I'm gonna click K here for the knife mode, and I'm gonna cut this area. So I'm gonna click here. I'm gonna go down here, zoom in on this one, and click, and then move here, and click, and then I'm gonna move here. Click, and finally finish the line here. Click and click enter. So now we have a cutting of the viewport. What we can do here is I'm going to select these and I'm going to click E to extrude it backward like this, and I'm going to go into solid mode. So now right here what we have is basically I'm going to move it a little bit backward so we have space for the lava, or maybe a little bit forward, I don't know. So now what we have here is if I go into viewport, as you can see we have a scene going on, and if I go into material view, okay, so as you can see the side looks white and we don't want it, so I'm gonna select this material. I'm gonna click the surface here and I'm gonna change it into holdout. So now what we see here is actually the background, and we are removing that area. Okay, cool. Now this is replaced successfully, and I'm gonna save it. Now I think it's time for Houdini to do its magic. It's time to export all those collider into Houdini to see what we can do with it. And I think okay, so once you create all those objects, now it's time to simulate some lava. Okay, for these we're gonna export these collider because we need them in Houdini. I'm gonna select both of those and I'm gonna go to File, Export, and I'm gonna say Alembic. Well, Alembic is a really good format, so I'm gonna call it collider, and I'm gonna say selection only, and yeah, that's it. Just click export Alembic and it will export your Alembic. And make sure to have a look on your frame rate, which is 58.94. I don't know why it changed, but it's maybe 59. Okay, now come up to Houdini right here. First of all, let's change the FPS to maybe 59.97, maybe 94 I think, and click apply FPS, and right here I'm gonna set the ending frame to 841. Now it can be different for your situation. Okay, so once you set it to 841, you might be thinking, well, why that long? Like the video is not that long. To be honest, this video was recorded by my friend, and he sent me this video over, and I'm really pissed off right now because he recorded it at 60 FPS, and I just hate it because I have to render that many frames. It can be different in your situation. Make sure to be on 24 FPS on your camera or maybe phone. It's much better, but for me, I'm done. Okay, so once you open up Houdini and change the FPS, let's create a geonode, and I'm not gonna explain it what geonode does. I hope you get it. I'm gonna go inside it and I'm gonna create an Alembic node to import the Alembic file. I'm gonna click this button and I'm gonna go to the location where I saved the Alembic. It's right here, alembic.collider.alembic. Select it and click accept. Now as you can see, we imported all the objects. Alright, the scale is off and I think it's going to affect our simulation, but I think it's okay. It's okay. We're gonna do something about it. So when you import Alembic into Houdini, if you look into it, it's just 2 points, which is not true. There are a bunch of points here, but it is pegged right now, so we have to unpeg it. For this, we're gonna add a convert node. This convert node basically turns this Alembic into a polygon mesh, convert to polygon. Now as you can see, the UV maps is also back, and also we can, if you look into the information, we can see all the points. Yeah, 36 points. Okay, so now the Alembic is imported. Now it's time to create some simulation. So it's going to be a demonstration of the simulation. I might change the emitter object, I don't know, but I'm going to show you how to do all the stuff. Okay, so now it's time to create a sphere. Maybe, yeah, sphere is okay. I'm going to create it and I'm going to grab it here. And if I look into it, that's the size of our sphere. And I'm going to move it up like this, and I'm going to move it to that direction. Oh, the scale is actually not off, it's perfect. And I'm going to scale it down as well, and I'm going to move it to here. If I look in my Blender scene and I go to wireframe, So I basically want to emit from here, from right here, so it doesn't touch the bottle and the hand. Okay, so I want to emit from here. And also, if I look into it, the simulation needs to start at somewhere. For now, we don't care about it. We're gonna play around with it later on. But first of all, let's create a basic flip simulation. Okay. So what I'm gonna do here is I'm gonna create a flip source, and I'm gonna put it here. I'm not gonna do it with the SOP flip fluid. I'm gonna do it with the DOP version of it. I don't know, but I like it. So I'm gonna look into it. And I'm going to wireframe. As you can see, you might don't see it. I'm gonna click D, and I'm gonna go to back geometry. I'm gonna scale up the points so you can see it, and as well as I'm gonna change the background to dark so you can see everything. And now, as you can see, we've got a bunch of points here. It is wireframe basically. If you go to solid mode, you will see SDF, but if I go into wireframe, you can see the points. So right here, I want particle separation to be 0.04 for now. No, not it's too low. 0.02. Yes, that's good. Okay. And I want to look into my collider as well. So let's go into smooth shade. Okay. So now it's time to create a DOP network. So I'm going to create a DOP network. I'm going to get the first one. You don't need to connect it, but I'm just doing it. So I'm going to go into DOP network inside. So inside it, I'm going to create a flip solver. I'm going to connect it to the output, and I'm going to create a flip object. Right now, if you look into it, first of all, the representation of points is not good. And second of all, the size of the domain, or maybe box, or whatever you're going to call it. But here, we call it, where is it? Volume motion, box size. So I'm going to set the box size to be 5, I think. Now, what does the box do? Well, the simulation will happen inside this box. So it basically helps optimize the flip fluids because they are heavy if you do it with the entire place. Sorry. Okay. So right here, I'm going to change it to particle field, and I'm going to remove this because we don't need it. I'm going to create a volume source, and I'm going to connect it to the post solve. Right here, I'm going to change it to source flip, and I'm going to say the first context geometry. So what it does, it basically grab the first input, which is this one. So it basically helps import it. And what does the volume source does? Well, if we only look into flip object, if I turn this off for now, just to demonstrate you, I'm gonna click this button here, and I'm gonna select flip source to import our object. So right here, if you look into it, that's our flip simulation. And if you play it, I'm gonna add a gravity force. So if you play it, it's gonna fall down. Okay. So if you only have flip object in your node graph, it means it's only going to use the particle you have right here. Okay. But if you add, if you go inside, if you add a volume source, it will continuously emit particle, and it will not stop until you tell it, until you set the activation to 0. So this volume source, what it does, it basically continuously emit fluid, and if you only use flip object, it will only use the points here. Okay. And the other thing is that I'm gonna right click on the particle separation, and I'm gonna copy it. I'm gonna paste it in the flip source because the particle separation here is 0.02, and inside it it's 0.1, which doesn't match. So I copied it, and I'm going to paste it right here. So it changed. I'm gonna get it back to 0.2. So these two parameters are connected now. If I change it here, it's going to change here automatically. So, and right here you can see the particles. And the representation of particle is a bit off, so you can come to guides, you can come to particles, and change the visualization to particles. And now, if I click D and go to geometry, I think the point size is a bit bigger, so I'm gonna grab it to 1 again. Close it. Okay. So right here, the volume source is turned off, and if you play it, this is going to fall down, but we don't need this. We want it to emit continuously. So now if you play it, it's going to emit continuously, and that's exactly what we were looking for. Okay, so now we created a gravity object. Okay, so now it's time to bring the collider into the simulation, but we're not going to use this one as a collider. It is just a representation of our shot. We will create some cubes here because look, there are a lot of problems that it makes as a collider, as an SDF, because it's a thin surface and there are a lot of problems that it's going to make. So don't use this geometry directly. You can optimize things out and make them better. So right here, what I'm going to do is I'm going to create a cube here, and that cube is going to be, I'm going to move it up like so. Oh, not you, but you. And I'm going to move it like so, right here. And I'm going to align it to this side. Control C, Control V. And now I'm going to move it to the other side, like these. And now I'm going to get another one, like so. I'm going to move it down. I'm going to edit right here. Now you might be thinking why I'm doing this. Well, because I experimented using this geometry collider and it did not work. There was a lot of work to do, so I just simplified the process. And yeah, that's our collider here. Now we're going to merge them together, like these, and we're going to connect it with this collider. So this is going to be our collision object, okay, for the screen here. And also I think I will need it in the back. Yes, I think I need it in the back. So I'm going to click Control V. I'm going to put it here. And what I'm going to do here is I'm going to move it, and I'm going to rotate it like this, and I'm going to move it backward. Like so. Yep, and that's our screen right there. And it's going to help us a lot. So if you look into this one, in this geometry I need this down, these other geometry. So what I'm going to do here is I'm going to click enter to go into edit mode, and then go to selection mode and select a 3D connected geometry. I'm going to select these, I'm going to click tab, and I'm going to add a blast node, and I'm going to say delete non-selected. So I have this geometry here. I'm going to create another null here, and I'm going to call it collider 2. So we're going to use both of those, and now it's time to import the collider into the DOP network. So right here I'm going to add a merge node, and I'm going to add a static object, and I'm going to connect these to the merge. I'm going to select the merge and turn these into mutual. In the static object, what we're going to do here is we're going to select our collider, the first one. You can turn it off from here, display geometry, and if I go to collider, if I turn this on, this is what Houdini going to use for the final collision. Now this is basically a quality, or you can say resolution slider. So if you increase it, the quality gets better, and that's what Houdini gonna use for collision. And I think that's looking good. I'm gonna turn these off, and I'm gonna turn on display geometry. Let's add another static node. In this one, we're gonna import the collider 2, and I'm going to connect these to the merge as well. Now if you turn this off, go to collision and turn on collision guide. You won't see it for some reason. And I think, wait a second. instead of this geometry, I think we can use ground. Okay, so what I'm gonna do is I'm gonna add a ground node, ground plane basically. And why I'm adding ground, if you look into this geometry, it has a lot of problem for no reason. If you turn on collision guide and turn off display geometry, you don't see anything, and you have to crazily increase this number to see something. And if you turn this into surface, like if you use the surface collision and turn this on, it will work, but it will extremely slow. So instead of using this static object, I'm going to create a ground plane. This is the ground plane that we're going to use. So right here, if I move these up and down, I'm going to turn on this on so I can see it. And now I can align my ground object with this one. It's not going to be perfect, but roughly matching. Yep, I think it's looking good. Delete the other one because we don't need it. And as you can see, we set up the scene. Now it's time to work on the simulation. The simulation is set it up, and right now if you play it, it's gonna look like this. It's just a basic fluid simulation, right? So now it's time to turn this ball into lava, okay, like a flowing lava. It starts flowing, not so viscous, but when it reaches the table, it becomes rigid and solid. That's what we are trying to create now. So to achieve this, first of all, we need to come up to Flip Solver and come to viscosity, turn on enable viscosity, and also viscosity by attribute, because we need this viscosity attribute. And to achieve the lava look, you need to create a node called gas temperature update node. So basically, this is the main node for this entire effect, and it does everything, okay? Because it has all the options for you. It uses temperature to have a higher temperature at the beginning, and once you go through simulation for a few frames, the temperature goes down and the viscosity goes up. So it uses temperature to do all the stuff. In order to use this node, we need to create a temperature attribute before the simulation. So right here, we're going to create an attribute wrangle node, and I'm going to connect it here. You don't need to write a lot of codes. It's just a simple f@temperature equals 1. So why are we adding 1? Well, because if you add 1000 on or 100k, it doesn't matter. It only read 0 and 1. If you set this to 0, the temperature is 0, but if you put in 1, the temperature is high. That's it. You cannot specify a higher value than that. It will still be the same. So yeah, let's go inside it. So right here, now what it does, it's going to use the temperature. In the beginning, it's going to have a higher temperature of 1, and when the simulation goes on in the timeline, you will see that the temperature goes down and the viscosity goes up, right? So let's play it and see it in effect. But before we do this, I think we can do it outside. And right here, I think I only need the flip object. Yep. And I'm gonna add the star into it. Okay, so it works. And right here, what we're gonna do is we're gonna create a color node. And in this color node, if you go into it, we're gonna change this to ramp from attribute, and right here we're gonna select black body, so we have this here, and right here we're gonna choose temperature. So now it's going to color all the particle according to its temperature. If it has a higher temperature, it's gonna be white, and it's gonna gradually go down to black if it has a 0 temperature. So we're gonna play it and see what we have. Okay, once we set up the color, if we play it, that's how it looks like. And if you look into it, it looks extremely uniform, and we need to break this, okay? In order to do that, first of all, we have to deform the source here, if I go into wireframe and I select this node, right here you can see those particles. We have to deform this sphere every single frame, so the new particle spawn on a new location and it breaks the trail. So to do it, we're gonna search for a mountain node, and we're gonna add mountain node here. And if you look into it, that's how it looks like. Now there is the amplitude, which basically the strength of the noise here, and there is the element size. So let's make it smaller and decrease the scale here. And if you go to sphere, you can increase the resolution of it to 15 maybe, something like this, and turn on the animation. Here is the pulse duration. If you play it, it changes. I want it to be faster, so decrease the pulse duration. If you play it, it's happening faster. Now if you look into the flip source, right here you can see the spawning of new particle happens, and it helps randomize the particles. Okay, so once you do that, now if you look into our simulation and play it, now it's not perfect, but with the time it changes, and if you have like millions of particles spawning, then you will not see the trails. Okay, so right now I'm gonna change the background again because I somehow changed it in between. Okay, so now if you play it continuously, if you focus here, it is extremely white, but down here it turning yellow, because if you look into our color palette, it's right here, and the more it gets viscous, the darker it gets. Okay, like the temperature here is 1, but the temperature goes down, down, down. Right now in this part, the temperature is right about here. I don't know the specific value, but it's on the yellow color. That's why we have yellow color here, and we have white here, because the temperature for new particles is high. Okay, so now it's time to play around with the gas temperature update. Here is the cooling option. It's the value, like it's the speed. Okay, it's basically the speed of cooling down. If you increase this value, the temperature will cool down faster. So we're gonna increase it to maybe somewhere 0.6, or maybe 0.6 is good. And also this is inner cooling system, which is used for the internal particles, and we're also gonna set this to 0.3. Now it's time to look into it and see what we got here, and save the file because it's important, and then play it. So right here, as you can see, now it turns yellow very faster, and when it reaches here, it's going to turn red, then it's going to turn black after reaching the temperature to 0. So now, as you can see, it's cooling down right now, and it's getting viscous in here. So if you look into it, oh, that's how it looks like. And I think it cooled down extremely faster. So what we can do here is, I think if we decrease the cooling rate, because it is cooling down extremely fast, and I don't want that. So I want it to have to make them cool down after some time. Okay. So now, as you can see, it's not cooled down yet, but it reaches the ground here, and right now it's the time for it to get colder. Yep, and as you can see right here, the viscosity is 0, but right here the viscosity gets into a higher value, and that's how you make this effect. So now I calculated it, and the starting frame needs to be 180 in the video. So I'm gonna set this to 180 right here on the .NET in the simulation here, and the simulation gonna start from 180. So, and I think I need to decrease this value a little bit, and I'm gonna save the file and this value as well. Cool. And yeah, if you want to change the viscosity values, it's right here. This is the minimum viscosity. This is when temperature is 1, the viscosity will be 0, and this is somewhere around 100K. This is when the temperature is 0, the viscosity gets to that value. You can increase or decrease it, it's totally up to you. And here is the solidify threshold. It's basically how faster or how solid the fluid gets. If you increase this value, the fluid will be extremely solid after some time, and it will literally look like a solid object, not a fluid anymore. So slightly increase it if you want. Maybe I can go with 0.19 maybe, yeah, and save the file. So what I'm gonna do here is I'm gonna look into this one. Oh, not this one, maybe that one. So I'm gonna render up the play blast to see what kind of effect we make, and after that I will be back. So I'm gonna click this button here and click start. Now what it does, it basically renders out the viewport so we can play it smoothly. So this is a preview of the simulation. If you look into it, that's how it looks like. So now what we can do here is you can replace the sphere with something else if you want. I might change it, I don't know. I can replace it with anything, maybe Suzanne hat from Blender or Pig hat from Houdini. It can be anything. And here, if you look into it, I'm gonna go one frame forward so we can see the particles. Okay, so this is the particles, right? You first need to convert this particle into mesh, and I'm gonna show you. Now, this is not a high resolution simulation. It is just a preview, okay? I'm gonna change the resolution here and decrease this value to have more particles and have more details in the simulation. But just to show you, I'm not baking it yet. I'm not caching it for Houdini user. So let's turn this into mesh and see if we can use the same attribute. Okay, so here what we're gonna add is fluid surface, particle fluid surface. Now you can do the VDB way, but I think it's extremely easy, so I'm gonna just add this node and look into it. I'm gonna change it into smooth shaded. So right now the resolution is not matching with this one, so I'm gonna copy this and I'm gonna paste it here, paste relative reference. Now it's connected with this one and it is 0.02, and now as you can see we have the shape of the simulation. Right now there's the option for transferring attributes, and I also want to transfer the temperature, so I'm going to type in temperature. So we have the temperature attribute here. Now we can connect the same color to this and we can have a look in it, right? So right here it is yellow for some reason, and if I play it, so if you have look into it, now if you play the simulation, if you're wondering why do we have the blob in the simulation at the beginning, well, it is because of that setting in the flip object. You have to remove this path because it is making a big problem. We are using the flip object for the initial particles. So right now, as you can see, the top part is white and it is turning into yellow, then red, and then it's gonna turn into black because it is lava. So yeah. Yeah, and that's how you do it. So once you convert this into the fluid surface, now you have to back the simulation. For this, we're gonna add file cache node before the surface node. I'm gonna add this file cache node here, and I'm gonna have a look into it, and I'm going to select it, and I'm gonna see if it import any attribute. Yes, it does. It does import the temperature, and that's what we want. Select a location for it and save it to disk. Okay, and then once you convert this into a geometry, those particles into geometry, what you can do then is also create another file cache node and also back this one, save this to disk so you can play it. But I think instead of this, you can directly add an Alembic node, ROP Alembic output. It will export the geometry as an Alembic file. Now you can also use USD, but I'm going to use Alembic, and I'm going to connect this to this one. I'm going to turn this into render frame range, and I'm going to choose a location, and then I'm going to click save to disk. What it does, it basically export your surface as an Alembic file that you can use inside of Blender. Okay, and if you look into it, it has a CD attribute, and if you connect this one into here, now it's also going to export the CD attribute with it, which is basically color attribute, which is this color ramp, or maybe you can call it temperature. So you can use it in Blender as well to color your simulation. And yeah, that's how you do it. And once you do all the steps, first of all export the simulation and then export it as an Alembic file, you will be able to import it into Blender, and we're gonna do it. So it's gonna take a bit of time to cache the simulation, and I'm also gonna change the resolution here. Right here I'm gonna set I'm gonna have a look into it and go to wireframe. So right here I'm gonna decrease the particle separation to 0.00 and 7. Now as you can see, we have like a lot of particles. It's a lot of particles going on here. And now we're going to export this as a BGO file and then export it into Blender. I'm gonna do this step. I'm not gonna record it because it's basic step, and once I export all those, I'm gonna show you how to import it into Blender and how to use it. Okay, so once you export your final simulation into a Alembic file, you can then import it into Blender. So inside of Blender, you're gonna go into File, Import, and click Alembic, and you will see this here. I'm gonna import it, and it will change the start frame, but I'm gonna get back to 1. And right here, if you, I'm gonna turn so I actually used Suzanne head instead of the sphere. It's super easy to use any sort of shape, just change it. And I just, if you look into it, this is the sphere that we used in the video, but I change it into Suzanne head. Okay, so here's the simulation. And the best part here is that in the data, if you go into attributes, it exported the CD attributes. If you look here, we actually had the color, which basically a CD attribute, exported with the Alembic file, so we can use it in material. So I'm going to go into material view, and I'm going to click new here. I'm going to add an attribute node. Once you add this node, you can type this name here. So I'm going to type in C and D, and then I can connect a color ramp just to test it out. I'm going to connect it to the base color, and as you can see, it is coloring the lava. So that's how we do it. And to change it, what you can do here is you can add more handles. This one is going to be the yellow color, bright yellow color, like this, and this one is going to be the red color. Right, so now it goes from white, yellow, red, and black, and when it moves on, it becomes darker. And I can just carry these to this direction, so we have more black color. Maybe this is too much, but I don't know. Okay, let's just do it. Yep, something like this. And now what you can do here is you can connect it into emission color, and you can increase the strength here. But what I'm going to do is I'm going to connect it to the strength as well. So, and I'm going to add a multiplier as well. So I'm going to add a math node in between the strength, and I'm going to change it to multiply. So if you increase this value, it's going to increase the strength of it. And I'm going to make it higher like this. And if I go into camera view, that's how it looks like. So right now in the beginning, the color of the Suzanne is entirely black. So first of all, let's do some render settings, then we're going to talk about it. I'm going to set the render engine to cycles and the device to GPU. Turn on denoise, and I'm going to come up to the film here, turn on transparent, and if you go into render mode, that's how it looks like. And select the camera, go into camera settings, and make the passport out to 1 so we don't see the sides, as well as in the background image increase the opacity so we can see the footage perfectly. Okay, so now select the ground object and go into object settings, go into visibility, turn it into a shadow catcher so it only catch the shadows, nothing else. Okay, so let's select the source and head here. I want it to have a brighter color in the beginning and then it turns into something else. So I'm gonna go into solid for now. Maybe material view is good. I'm gonna add a mix shader here and I'm gonna duplicate it like this, set the emission to 0 and connect it into the shader. Now if it is 1 it is going to be a brighter white color, and if it is 0 it's going to be the original lava color. So right here I'm gonna set this to 1 from frame number 180, and afterward what we're gonna do is up to here we're gonna set this to 0. So like when my friends say start the simulation, the colors start to change into dark and it's going to look like this, right? Perfect. And if you go into render mode in the end here, you'll be able to see that it's dark, and now it's time to add some lights into it. So I'm going to add light and area light. I'm gonna move this up and I'm gonna increase the strength, move it to here, and I'm gonna set the colors a bit hotter like this, and I'm gonna go into solid mode. I'm going to duplicate it here and here as well. Cool. So now what we're gonna do is, if I go into render mode, now you can make the lava material better if you can. You have the full control here, but I think that's it. That's the entire effect. So now let's do some final settings. I'm gonna change this to, I'm not gonna composite it in After Effects or anywhere else. I'm gonna finish it right here. So I'm gonna set the location here to this one, and I'm gonna click accept. And once I do this, I'm gonna turn this into FFmpeg video, and then I'm gonna go into compositing here. I'm gonna click use node, and I'm gonna click add an alpha over node right here. I'm gonna add a weaver node as well, and I'm gonna add an image sequence node. Sorry, not an image sequence, a movie clip. I'm gonna click open, and I'm gonna open my video here. It's right here. I'm gonna connect it here. Actually, I'm gonna connect this to the top and this to the bottom, something like this. Now we don't see anything. It's because we haven't rendered anything. So I'm gonna set the max samples to 100, and that's it. Now if you want, you can save the entire video, but I'm going to save an image. You can render animation and you will have the final video. I'm gonna click render an image for now to just show you the result. Oh, these planes is also rendered. You can turn them off if you want. It's gonna take a bit of time, but we can wait for it. He's demoing right now. And here is the result. Now you can change it however you want. You can change the screen, you can change the shading of the simulation, but this is basically it, right? And I will see you in the next one.